All right, this example is solve 7 tan theta equals 2 root 3 plus tan theta on the interval 0 to 2 pi. We're going to next transition to solving on a closed interval to finding what we call general solutions. And that's one extension from this. You could picture a lot of this trigonometry or even really all math as a big web, or like when you were, I don't know, do you guys still do brainstorming where you have like your topic and then like the ideas and everything kind of webs together? Maybe something over here links back to something over here, you know, it all comes full circle. So solving trig equations, we can go one route where we are solving by hand with the unit circle, no calculator, and we can find answers between 0 and 2 pi. But then we could branch off and find all your solutions, an infinite number. Or we can go a different route where we're solving ones that aren't on the unit circle and that require the use of a calculator. And then from there, we could also find all solutions by the use of a calculator. So a couple different directions we can go in. Before we fix the typo on this question, it actually could have been done using a calculator. So maybe if you have a tutor or a friend that kind of knows the next part, or maybe if you really remembered from your days in geometry, then maybe you use the calculator to sort of solve the question before we fix the typo. Sorry, my long chat about it. It was a 3 on the paper. But let's go from here. Sometimes you guys get a little awkward when we are trying to solve and your coefficient is a 1, because I feel like we forget some pretty simple stuff. So what would I do? Remember, we're solving for theta. What would I do first in order to get one step closer to isolating theta? What would I do first?
You would combine like terms.
Okay.
Like, for instance, 7 tan theta minus tan theta make 6 tan theta.
Perfect. You're going to subtract it off from both sides. So I was going over this when someone came for extra help yesterday. And when we went over this step, they were like, oh my gosh. They're like, I don't know what I was thinking. They were like, I was making like tan theta go away and I was getting 7. They're like, I wasn't thinking. That happens, guys. Like, you're going to look at this stuff sometimes and your brain's going to play tricks on you. So just go slow. Take your time, okay? So now that was Victor, I think, right? Perfect explanation. This, what do we call this occurrence right over here? What do we call that? When it turns to 0, I said you're allowed to use a word, but we're not allowed to use that word, say, for this.
Cancel.
Cancel. This is reduce or simplify. You can call that canceling, okay? It becomes 0. This becomes 1, just so our vocab is on point, you know? All right, so we have 6 tan theta equals 2 root 3 on this side, okay? Theta's our variable. I know it's not an x. It's okay. What can I do? We're trying to get theta alone, but again, Shrek with the onion, all right? Onions have layers, donkey, and you gotta peel the layers off. So the first layer we peel off is gonna be 6. Then the next layer we peel off is gonna be tan, and deeper into it until we get theta alone. So what do I do to both sides here?
Divide by 6.
Thank you. Good. Don't subtract 6. I know sometimes, I don't know why we want to subtract 6. Even worse, okay? Pause for a second if you're writing. If this is a negative number as a coefficient, I always see you guys in your work adding it, because I think you see minus as subtraction and you're like, oh, I have to add. But remember, it's attached to tangent with multiplication, not with addition or subtraction, okay? So you would divide. Emerson, you have a question?
I think it's tan equals 3 root 3.
Right. That's on the worksheet. When you looked at the homework post, I wrote on the post to fix the typo on the sheet. So that's what I was mentioning before. So you might have just missed when I said that, okay? So when it was 3 root 3, it could have been solved by a calculator. That I will actually do that full example when we do calculator questions, okay? I will save it. So if you tried it, like I mentioned before, if anyone tried it that way and maybe you got help from a friend or a tutor, you could see if you did it right or correctly. Here we are reducing or simplifying those sixes. What does the right-hand side simplify to? Any brave soul?
Radical 3/3.
Beautiful. Radical 3/3. Radical 3/3. Now, here you have a little flexibility for the time being. You could just read it as a question to yourself and use your knowledge of, well, what did I just do with him? Oh, it's over here. Of TanTan, the meditating man, right? We could use our knowledge of TanTan, the meditating man. We know where it's 0 on the sides. We know where it's undefined. And we know his little wisdom when it comes to memorizing these. Or Cotan, his twin brother. Or you could just work on memorizing the tan values this way. Or you could do it the long way every time. But nobody's got time for this, guys. That's great. I want you to know where it comes from, but we got to keep it moving, you know? Ask yourself the question, the tangent of what angle or angles between 0 and 2 pi equal √3/3. Again, the way you ask the question, the tangent. I'm writing it out as a sentence so that you can have a point of reference so you know how to ask yourself the question of which angle, and we'll do that little parenthesis S move because it could be more than one, between 0 and 2 pi equals √3/3. So who can tell me one angle? I just gave away that there's two. Probably should have been a little slower with that. One angle, and then somebody else will give me the other one. I see hands up by Lispel, Gispel, Emerson. Who else is going to raise their hand and try? I know you could do it. Don't be lazy. Just hit Control. What is it to unmute? Control D to unmute yourself. Sammy's got her hand up. Marco. All right. Let's see. Jeremiah. Jeremiah, you could do this one. I haven't heard your voice today. Give me one angle.
Over 3. No, over 6.
Good. Because he's so wise, TanTan, the meditating man. He sees 2 3s make a 6. Obviously. So pi/6. And then that was the quadrant 1 angle. We said tangent's positive in quadrant 1. We think tan lines, positive slope of a line. What quadrant does it go through? 1 and 3. Negative line, negative slope goes through 2 and 4, right? So what's the other angle? What is the other angle? Do you want to go for it? I know, Sammy, you had your hand up. Do you want to say what the other one was?
Would the other one be pi?
Pi/6 is 1 in quadrant 1.
Maybe.
You got it.
5 pi/6?
What quadrant is 5 pi/6 in?
Quadrant 2.
Yeah. And then where is tangent positive, though? Which 2 quadrants is tan positive in? Remember, we did that back lesson 7 and 8 a lot. And I talked about
in 3 and 1.
Right. It's positive here if you have a line.
So 7 pi/6.
Good, good. 7 pi/6, okay? 7 pi/6. We're going to say the same thing, Marco? I don't know if Marco, if you were unmuting yourself. I was just checking if you had the same answer. Now, anyone with your hands up, do you guys have a question you could just ask, or were you in agreement? Are we good? Comments, questions, concerns? Nobody?
Wait, so
go ahead.
can you say one more time how you got 7 pi/6?
Okay, so the 2 quadrants that we know, because we have a positive ratio right here. Opposite over adjacent, you could really think of it that way if you want, TOA. Or we could just remember that we got these answers when we did it the long way, we got these answers by doing sine over cosine every single time. So here, look, tan of pi over 6 is sine of pi over 6 over cosine of pi over 6. We use the quotient identity, right? We got 1/2 over root 3 over 2. We did a little keep, change, flip, and we got root 3 over 3. We have a little note here. We said it's positive here as well. If we were to do the work for this, so I'm just going to kind of throw this in here with a different color pen for a minute, or marker. Sorry. If I were to do 7 pi over 6, for example, I'm going to squeeze a little 7 in here, okay? That's this one right here. Well, the sine of 7 pi over 6 over the cosine of 7 pi over 6, sine of 7 pi over 6 is negative 1/2. Cosine of 7 pi over 6 is negative root 3 over 2. And what happens when you divide a negative by a negative? What do you get?
A positive.
Right. So that's why, that's a little evidence for us about how tangent will always be positive in this quadrant, because we know sine and cosine are both negative. And since tangent by the quotient identity is the ratio sine over cosine, then tan's always positive here. So if you just memorize that and you're like, I just know positive in those quadrants, okay. But if you want to understand it a little bit more, that's where it comes from, okay? So 7 pi over 6 is that same root 3 over 3 answer. If I wanted to know where tangent was equal to negative root 3 over 3 though, let's see if you really are getting it. If I asked you guys, where does tangent, here's a little extra example. Where does tangent equal negative root 3 over 3? Who can tell me between 0 and 2 pi? Obviously, like, I could go on and on with infinite answers. All right, Sharon, what do you think? Where does tan equal negative root 3 over 3?
5 pi over 6.
Good. That's one answer. And does somebody know where the other answer would be between 0 and 2 pi? Do you want to try Lispel?
11 pi over 6.
Beautiful. So 5 pi over 6 and 11 pi over 6. So all the pink are all the angles over 6, right? All the pink are the angles over 6. They're all root 3 over 3, but you have to figure out positive or negative, and you can just use what we know from back in lesson 8. I know we're only in 14 now, okay? But over there to figure out the answers, okay? Now, from here, flipping back, does that help a little bit, Logan, clearing that up?
Yeah, that helped. Yeah.
Okay, good. Any other questions before I end this little recording for this particular example? We're okay on it? All right, so this is sort of like part A, and we're gonna have a part B video with the next lesson when we're gonna go and find that general solution, which we did for a do now in our last class. But if that was good for you and you think you understand this type of example, you could thumb up it for yourself if you want. And if you think that this is something that deserves more of your attention that you might not remember a month from now, put a thumbs down. So these are the things that you know I should look this over because I didn't feel super confident on it. It's just for your own records inventory, okay?